So, welcome, Arsalan. Looking forward to see you.
Hello. Yeah. Hello, everyone. Actually, I should first share my screen. Okay. I don't know if you can see my screen.
That's good.
Yes, we can.
Is it clear for you?
Yes. Yes.
Yeah. Okay. Well, thank you very much for giving me this opportunity to be to give a talk about the determination of ancient shoreline and anthropogenic sites using remote sensing technique. Actually, I have contacted by Dr. Jafar and Risha to give this presentation. After that contact, really, I was not working with the archaeology, and I was not interested with that. But after this contact, really, it is good to do some work with this field, and really we can do some work to integrate between remote sensing and anthropogenic archaeological studies. I will give you just some outline. I'll introduce about the study area and the previous study. Also, I will show you the data which I used in this study. Then I will shift to methodology. After that, I will show you some results. Finally, I will conclude what we have done in these 2 months. First, to begin with the introduction, the change in sea level depend on the tectonic erosion and change in climate, but that should be globally, not like a small sites. And after for example, if you have an active tectonic and low erosion and glacial, you will find there is no change in or you will find you have a regression in the sea level and vice versa. And this shoreline, the change in the sea level definitely will affect on the location on the ancient anthropogenic, because normally the people like to stay near the rivers and also the seas, and these sites in general has a higher elevation than surrounding area. For that, we use the previous information and this character to do our work. To say something about the previous work, historically, the peak of the glacier until from the mid of the glacier until the 14,000 before present, actually there's just a few or a small waterway represent the present Arabian Gulf. After that, we found that there's a transgression of the Arabian Gulf after 10,000 before present. Then the water or the shoreline is reached to the present shoreline or more near Ur and Eridu in the before like 6,000 before present. And finally, we have the shoreline is near Fao. Again, I will focus on two main objectives, which is the determination of the ancient shoreline of the Arabian Gold depends on the previous study. geological previous study, and then I will use the remote sensing technique to detect the anthropogenic sites, the ancient anthropogenic sites. First, I will give you some information about the term of Mesopotamia, because all they say Mesopotamia, but the geological means something, and the archaeological archaeologist means another thing. Lithologists mean another thing. If you look to the red boundary, this is the boundary represent the what the archaeologists mean about the Mesopotamia. While the geologist or the person who interested with tectonic mean the area between the high folded zone and also the plateau or the stable zone in Iraq, which is represented by the black boundary. For the lithologists, they mean with the Mesopotamia, they mean this gray shell file, which is reached to 55 meter, has a length about 625 kilometer, and width about 225 kilometer. But all they agree that the Mesopotamia located in the southern of Iraq. All they agree that the Mesopotamia has a north west southeast direction. Okay, then for that I selected a typical study which is located in the Mesopotamia that all agree that it is a Mesopotamia, which is near the Nasiriyah. And also I selected another area, which is the Arabian Gold, to show the rising and decreasing depending on the remote sensing data and how we can modeling and show the boundary of the Arabian Gold depending on the geological data. Because, sorry. Before that, I start to collect a lot of data. For example, here is a map. This map was produced by Yaqub in 1985, which is one of the good report in the Iraqi Geological Survey. This geological map show that we have anthropogenic sediments in this study area. And exactly it's located with Larsa and ORAC and so on. All these areas was reported that it has an elevation that has a higher elevated than the surrounding area. Some of them, for example, the big cities or towns has elevation reached to more than 10 meters, while some of the small areas is around 5 meters. Also, for example, the natural levees, which is used for as a rice field in the south, it has an elevation more than 1 meter more than the surrounding area. Then I'll shift to the data which I used. I used about 63 scenes of the digital elevation model, which of type of the SRTM, shooter radar topographic machine. It has a resolution 30 meter, and after mosaic and after mosaic this data, it was ready to process. Then I also used the GPCO data with a general bathymetric chart of ocean. It has a resolution 15 arc, and that's mean equal to 450 meter, to show exact depth for each rising or decreasing for the elevation in the Arabian Gulf. This data show the bathymetric of the surface under the water. Then I use multi-spectral data. I start to use Landsat only. I use 2C to cover the beach of the Arabian Gulf, to be sure about the present day shoreline for Arabian Gulf. Then I used QuickBear data, 63 group scene, sorry. And this QuickBear data, it has a 60 centimeter resolution, and it's really good to show the field in detail and decrease the time for field work. So as an example here, the ORAC in the QuickBear, and you can see this small area, how it's clear with this data. This data is pie sharpened with 60 centimeter. Then I use our field data. I suggested a project for 6 years long. We covered all Iraq, included the Mesopotamia, this data with a scale of 250,000 maps to cover land use, land cover, one of the land use, land cover anthropogenic, and we detect that in the lab, and then check all this data in the field. For example, here's some the data which collected. This is a part of the sites in this study near the Nasriya or surrounding Nasriya, and we found some of these archaeological sites. I don't know if it's very ancient or not. It's actually it need someone who is specialist with that. The importance of this data that normally this data normally found it far from the roads, and need like a geologist to detect that, because we know how to reach to these sites. Also, as I told you, I use the previous data to check also the QuickBear, and also the previous map to be accurate about our result. I cannot forget there's an index for the archaeological sites by which is include this area include 11 maps. These maps have been georeferenced, and after that inserted with the ArcGIS program, and after that digitized with add all the names of, for example, here's the data which is involved in ArcGIS database, and we add as the site name as shown in this map. Then shifting to the methodology, first I'll start to make a surface to convert the digital number for the Landsat to surface reflectance, and to remove the haze and aerosol effects. Then after that, I get do a mosaic for 2 scenes to get this Landsat mosaic show the Arabian Gulf boundary near Al-Far. This boundary, this image show RGB 543. And I use the NDWI, and that's mean normalized differential water index and modified normalized differential water index to detect the boundary of the Arabian Gulf. And we use a threshold 0 to separate between the land and the sea or the water. And here's exactly how to detect the shoreline. Finally, to be sure about what is published by Millie and 40 in 2019, and also he's reported that he stated that Akrawi 2001 stated that the shoreline was far between 26.
I think we have a problem again.
20
We cannot hear you.
with me.
Yeah, now
You cannot hear, or it's clear?
it was a break.
Now
So
it's okay?
we can hear you now.
It's okay?
Yes, yes.
Yes, it is now okay.
Yeah, it's okay. 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 Can I continue?
Yes, please. Continue, please. Yeah. Now it's a break again.
It's clear now? وفاء بس طفي الانترنت عافية.
It's just the connection. It's just the connection. Now it's
now
okay.
it's okay
Maybe if
or
you cut
not?
video, we'll have
Okay, I will cut it. Just wait, please.
it's a small bandwidth.
Anyway,
Yeah,
okay,
it seems to be okay.
okay. Okay, sorry. Therefore, to be sure about the state which is offered by Billy and 2019. Also, it's by Akrawi 2001. That the buffer that the Arabian Gulf before in 2000 in 6,000 before present. Was far from the present shoreline, about 260, 270 kilometer. We make a buffer about that and found that almost all the ancient towns, it's in underwater actually, and but they agree it's a coastal towns. For that, it's good to model the shape of the Gulf, Arabian Gulf, depending on the remote sensing and geophysical data. For that, I make a literature review about the really it was heavy because I am not before I was not interested with archaeological work. For that, I found this one of the good papers, which is published by Lambic in 1996 about the elevation or sea level elevation or change. He stated that there's a table or a figure. I converted to a table that showed that the elevation, for example, for 18,000 was minus 106, and in the present is 0. I use the threshold model to represent the Arabian Gulf shape for each level. Also, for the second part, I use something called a topographic positional index, which is show the area which has high more than surrounding area, and its need like mean map. And also it needs the elevation. That means I should calculate the mean of the pixels, which is located in the center. For example, I take a kernel. Here's an example for that. I take a kernel, then I should take or calculate the mean of this pixel, for example here. And after that, I calculate the mean of that. Then I will make just a simple equation by subset this on this, and finally I will have the elevation of the each pixel. I use several kernels to detect that, such as like 11, 21, 31, and 51, 101, and 201 to get the optimum kernel to find the big cities which is located in this area. I selected 201, which was the best, and used a threshold 500 meter to show the sites which has elevation more than 5 meters because of depending on the literatures. Then I convert raster to vector. I found these locations for the TPI result for the sites more than 5 meters. Finally, I do the validation using the quick pair field data and previous map, and after that, doing the overall accuracy commission and also omission. Just shifting to the result, and I will go through. Here's the sea level depending on the data with the 18,000. And then we have it, we have it with 14,000, then in 10,000 before present, 10,000 years before present, and after that 6,000 before present. And we found here that Ur, Eridu are coastal towns, while Lagash, Larsa, Uruk, it's a marshland cities. And here's the sea level in 4,000 years before present, and now the shoreline of Arabian Gulf. For the result of topographic positional index, it's clear to find this. It's like a moon. The city is like a moon with white color. Here's Uruk, and here is the exactly the detecting TPI. Here is Larsa, and here is exactly detecting on Larsa, and also that is exactly for Tal Laham, also for Tal Al-Aqarib, Girsu, and Tal Chokha as well, and Ur. The main problem which has faced with the TPI that the TPI also detect the modern cities like Nasriya, because it has a height more than 10 meters some buildings, and 5 meters. It detected, as you can see, but that can be managed by, there's an index called normalized differential urban index, which can just remove it from the TPI. Also, I have a problem with the sandy dunes, which is really a complicated problem because you cannot separate between sandy dunes and also archaeological sites. These archaeological sites is covered, some of them is covered by sandy dunes. And for example, here's an sandy dunes, and it looks like ancient cities, but actually it is not ancient cities, sandy dunes. What is there's a hint that the sandy dunes has a elongated shape, and we can get a benefit from this character by make a equation, and normally if you look to these sites, it has a circle shape, and we can maybe separate between them. Just for recap, I can say the accuracy of detecting of anthropogenic site could be improved by including additional data about the sandy dunes. Also, it can be improved by using the length and width equation for each segment. Then the TPI kernel size has a direct relationship with the size of the height of the anthropogenic ancient sites. Also, the ancient shoreland of our Arabian Gulf is located about 190 between 190 and 230, not 260 to 70 northwest and the urban areas. I'd like to give a thank for all this organization to give me this chance, also to help me for finish this like a short paper. Thank you.
Thank you very much, Arslan.